Find the surface area of y equals x to the 1/2 minus 1/3 x to the 3/2 about the x-axis for 1 less than or equal to x less than or equal to 3. Y is x to the 1/2 minus 1/3 x to the 3/2. Y prime or f prime of x is therefore 1/2 x to the negative 1/2 minus 1/3 times 3/2 x to the 1/2. Rewriting this as 1/2 the square root of x minus the square root of x over 2. F prime of x squared is the square root of this binomial 1/2 root x minus root x over 2. Multiplying this out, we have 1/4x minus 2 times 1/2 root x times root x over 2 plus x over 4. Simplifying this further, 1/4x minus 1/2 plus x over 4. We then add 1 to the square of f prime of x. This is 1 plus 1/4x minus 1/2 plus x over 4. 1 minus 1/2 is 1/2. This simplifies to 1/4x plus 1/2 plus x over 4. But this looks like the previous trinomial, but this trinomial is the square root of 1/2 root x minus root x over 2. Therefore, this trinomial is the square root of 1/2 root x plus root x over 2. Using the formula for the area of the surface of revolution, S equals the integral from a to b, where a is 1, b is 3, 2 pi times the radius of revolution is the height of the function x to the 1/2 minus 1/3 x to the 3/2. And the differential arc length is the square root of 1 plus f prime of x squared, which we found it is 1/2 root x plus root x over 2. The square root of the square canceled out. We end up with the integral from 1 to 3, 2 pi, x to the 1/2 minus 1/3 x 3/2 times 1/2 root x plus root x over 2 dx. Before we use the fundamental theorem of calculus to evaluate this integral, we will simplify the integrand by multiplying the terms. X to the 1/2 times 2x to the 1/2 is 1/2. X to the 1/2 times x to the 1/2 over 2 is x over 2. 1/3 x to the 3/2 times 1/2 x to the 1/2 is 1/6 times x. The coefficient 1/3 times 1/2 is 1/6, but the power is 3/2 minus 1/2, which is 2/2 or 1. The last terms 1/3 x to the 3/2 times x to the 1/2 over 2. We add the powers 3/2 plus 1/2, which is 4/2. And so it is 1/6 x squared. We still need to combine like terms. 1/2x minus 1/6x is 1/3x. This integral is now 2 pi, the integral from 1 to 3, 1/2 plus 1/3x minus 1/6x squared dx. We can now find the antiderivative of each of the terms. The antiderivative of 1/2 is 1/2 x. The antiderivative of 1/3x is 1/6x squared. And the antiderivative of 1/6x squared is 1/18x cubed. We then apply the fundamental theorem of calculus. Plug in 3 into this antiderivative, we have 3/2. Plug in 1, we have 11/18. 3/2 minus 11/18 is 8/9. And so the surface area is 16 pi over 9. It is the exact area.